line spectra of hydrogen atom. Now, after understanding the Niels Bohr's model of atom and its postulate, the advantages of the Niels Bohr model, let us now understand the line spectra of hydrogen atom. Basically, in this we will understand how Bohr explained that we are getting line spectra in case of the hydrogen atom molecules or hydrogen atoms, and how he explained this line spectra. But first, let us understand what exactly is a spectra or spectrum is. See, the word spectrum is a continuous band of light and dark lines or bands. It's basically whenever the energies are arranged in the increasing or decreasing order of their frequencies or wavelength, the pattern which we get is called spectra or spectrum. Like we know, we have Vibgyor, we know that whenever a white light is passed through a prism, he passes a normal white light through a prism, it gets what? Split up into its 7 colors. The color which is having the lowest wavelength gets what? Gets deflected for most. So what we get is violet, indigo, blue, green, yellow, orange, red. So this is what the spectra which we get. So what is spectra is? It is the arrangement of the radiations. When the radiations are arranged in the increasing or decreasing order of their wavelength or frequencies, the pattern which we get is called spectra or spectrum. Now the spectrum can be continuous or it can be line spectra. Let us understand first this. A spectrum is said to be continuous if it's different, the patterns of the radiations which we are getting are overlapping each other. There is no gap between them, like the one which we get from when the splitting up by the splitting of a normal white light, which is called your rainbow or Vibgyor. In this, violet is merging with indigo, indigo is merging with blue, blue is merging with green, green is merging with yellow, and so on. So there is no gap in between. One band after the other are continuously arranged, and this is how what we call as a continuous spectra. Now, continuous spectra is mainly obtained whenever we have splitting off of the EM radiation from a source of a light. But then what is exactly is line spectra? Now, in order to understand what exactly is a line spectra, we must understand again a very basic thing. Suppose we have this particular atom and electrons are present in this. We have incidented certain radiations like normal, suppose we have incidented a white light. Now what happens is, we have given the light to this atom. This light is which is having certain energy given by h nu. Now this light is being absorbed by the electrons, and what happens is, now these electrons will get excited to higher energy level, like this. They come back then to their original state, and they emit the different amount of radiations in the form of again h nu. We know the formula, that's called Rydberg formula, and Rydberg constant is involved in that. Now we have two conditions. Now what are the conditions is, like suppose we know that white light is having all 7 colors: violet, indigo, blue, green, yellow, orange, red. Out of these 7 colors, yellow is the one which got absorbed by these electrons in the excitation. That means what? All rest of the 6 colors are reflected back. Now remember, not reflected exactly back, they just pass through it. So the other 6 colors just gets passed through it. So now, and yellow gets absorbed, and the electrons, when it gets excited, after some time they comes back to their original ground state, and they they emit out the different amount of energy again in the form of radiation. Now we have therefore two types of radiation which are coming out from the atom or the substance or the matter particles or whatever we will take. One will be the one which are actually coming out after the electrons coming back to the ground state, and the one which actually are not absorbed and are straightly passed through the substance. Now what will happen is, if we allow this radiations to get split up again through the prism, or if we allow to have the spectra of these radiations, what we will find is these radiations will have only one spectra of yellow region, because it is only the yellow light which gets absorbed. Whereas if we try to have the spectra of the radiations which are actually passed through this atom, what we get is violet, indigo, blue, green, dash, orange, red. So there is a gap here. There is a gap here. Now this spectra is called emission spectra, and this is called absorption spectra. I told you this is called emission spectra and this is called absorption spectra. Remember, both of these are negatives of each other. What is emission spectra is? Emission spectra. It is the spectra which is obtained from the radiation which are emitted out. These are the ones which are emitted out by the substance or by the atoms. Then what is absorption spectra is? See, it is the spectra which is obtained from the absorbed radiations, which are actually allowed to pass through the substance. Part of it is being absorbed, rest is being thrown out or just allowed to pass through. We take the spectra of that, we can find out which region has been absorbed by the atoms or the electrons by of the atoms. So by seeing the absorption spectra, we can find out which region has been absorbed, because that region comes out to be in the form of a dark region. This becomes your dark region in the spectra. So from here we can make out the yellow region has been absorbed, and so now we can make out the emission spectra will be what is of the will be in the range of yellow region, and that is why in the emission spectra we get a yellow band. So this is a very simple explanation that what exactly are the spectra are, like I told you, continuous and line spectra, and these spectra which when we take out are in the form of either what, emission or absorption. Now what is most important to note is, the emission are the most important one for us, that these emission spectra are not continuous. These emission spectra are not continuous, they are in the form of They are in the form of light and dark bands, which are actually appearing like lines, like what we have very similar to the barcodes which we find on the products usually nowadays. So what we get is the emission spectra of atoms and molecules are in the form of series of light and dark lines called line spectra. Now the question comes, why we are getting lines? Why we are getting dark lines, light and dark lines, and there are gaps, and how they are in the form of series? Let us understand this. Suppose we have these energy levels, like this is the first, second, third, fourth, fifth, sixth, and so on. Electron gets excited to higher energy level, like it moves to the fourth energy level, and then it has to come back. Now we never take one atom. Even if we take a very, very small amount of the substance, it will be having what, millions and millions of the atoms and the molecules. Now when we give energy to these atoms or the molecules, the electrons get excited to energy levels, higher energy levels. Definitely the excitation to the higher energy level will not be again the same, because all of them will not be having same amount of energies. So once they get excited, again what happens is, when they are coming back, the electrons in the different atoms of the molecules will follow different patterns. What different patterns? Like electron, once it is in the fourth orbit, in some of the atoms may be coming out directly to the first orbit. In some cases it will be coming back to the second and then to the first. in some cases then to the third, then to the second, then to the first, then in some cases then to the fourth, then to directly to the second, from fourth to third, and then directly from third to one. So like this. So all sort of possibilities of the electrons coming back to its ground or the first state can be considered. All are probabilities. All will take place. And remember, each of these transitions will give out certain radiations. The energies of these radiations we can easily calculate out. It will be equal to what? The difference of En2 minus En1. And what is most important to notice, since these system of orbits is quantized, energy difference between two successive or any two orbits is also fixed. So the transitions between these, that is why between these two energy levels will also be of fixed values, and that is why they fall under a series of what? Bands. Like the hydrogen spectra which we observe is in the form of series of light and dark lines, which are actually they are in the form of 5 series, like 1, 2, 3, 4, and the 5th one. They have been named on the basis of the scientists who have actually discovered them. So these are the 5 series of light and dark lines which we get in case of hydrogen spectra. In hydrogen atom, we get these light and dark lines in the form of 5 series, which are named after the scientists who have discovered them. The first one is called Lyman series. Second is called Balmer series. Third is called Bastian series. Fourth is called Brackett series. And the 5th is called Fund series. So we get lines not continuously. There are in the series of light and dark lines which are actually named, and they are into the 5 groups or series which are named after the scientists who have discovered them, are called Lyman, Balmer, Bastian, Brackett and Fund series. The question comes is, why we are getting these 5 bands and why we are having such number of lines. I can explain you this again. Like suppose we have first orbit, second orbit, third, fourth, fifth, then sixth and so on. What we find is, once the electron gets excited to higher energy level, like the 5th one, when it is coming back, like it is making a transition from 5 to 1, the energy difference will be fixed. It can come back not directly from 5 to 1, it can come back to the 2 and then can make a transition to 1. It can come back to the 3rd and then can come back to the 1. It can come back to the 4th and then can come back to the 1. Or it can come back from 4 to 3, 3 to 2, 2 to 1. So all possible transitions can be considered that happens in the different atoms or the same material, the substance which we are taking. And that is why we get different lines. Why these series? Because these energy differences are again fixed, and it is taken as whenever the transition from any higher state is taking place to the first one, the lines will fall on Lyman series. The second, that means what? The first orbit is associated with Lyman series, second orbit is associated with Balmer series, third orbit is associated with Bastian series, fourth orbit is associated with Brackett series, and fifth is associated with Fund series. So this is how we have, and the energy differences of these orbits, since it is fixed, any transition will fall into these series. Like suppose electron is making a transition from 3 to 1. So this transition's line will fall, since it is coming back to Lyman, it will be in this Lyman series. Since like electron is making a transition from 3 to 2, so it is coming from 3 to 2, the second orbit, Balmer series. So the transition, the corresponding to this line corresponding to this transition will be in the Balmer series. Similarly, suppose an electron is making a transition from second to fourth to second. Since it is falling to the Balmer series, the line corresponding to this transition will again fall in the transition series. If suppose a transition is made from 6th to 4th, the line for this transition will be in the bracket series. So this is how we have the 5 different series. Now let me take you to their exact formula wise values. Now we have always been taking N1 as the lower energy state, N2 as higher energy state. Now remember, Lyman, Balmer, Bastian, bracket, and fund. So these are the series we have. What is the lower energy level for them is? For this is 1, 2, 3, 4 and 5. What all the excited levels we can have for this? It can be 2, 3, 4, anything. For this it will be 3, 4, 5, anything. It can be 4, 5, 6, anything for this. 5, 6, 7, anything for this. 6, 7, anything for this. So electron when it is exciting from 6, 7 or higher, any higher energy level to the 5th level, the line for this transition will always fall in the fund series. So this is how we make this. These are the systems we have fixed. You need to also know the region of your EM spectra to which these bands actually are belonging. Lyman belong to you, remember, in the UV region, so it will not be visible to us. Balmer is the only one which is lying in the visible region, so it will be visible to us. Like all these Passion, bracket and fund, they all are in IR region, so they won't be again visible to us. So this is actually their placements. We know the continuous EM spectra, and here these lines are lying, and this is what is the atomic spectra is, and this is how the Bohr explained how these spectra originates, and this is how we have the atomic spectra of hydrogen not continuously in the form of series of light and dark lines, which are given out in the form of these 5 series. The formula finding out the wave number of any of these during any of these transitions is the same, which is wave number, or 1 by lambda is equal to RH 1 upon N1 square minus 1 upon N2 square Z square. So this is what is the formula is, whereas this RH is 109,677 per centimeter. So this is what is your hydrogen atomic spectra is, and this is how it has explained the line spectra of hydrogen atom.